All right, welcome to this week's Ronin Seminar. This week we have Ruth Duerr coming back to give us part two of her talk, From Data to Information. Go for it.
Thanks, John. So last time I had talked about how there were really kind of four stories that I wanted to relate that are all related to sort of the same topic, which is really, how do you get from data to information to knowledge to being useful stuff that people could use in their everyday life or to solve problems or things like that. And last time we went through parts 1 and 2, where I gave a little bit of a condensed history of, the birth of data management told through the lens of the International Polar Years, which started in 1882. And obviously way back in the very analog era, and then moving forward to modern day, and how data management had to transform over that time from, basically being file cabinets and archives and literature to being digital data. And then we talked a little bit about what data today really is. And I had to introduce the concept of an ontology spectrum where we can start talking about how things become interoperable and what kind of resources you need in order to make that happen, where you have taxonomies and thesauri, and then these conceptual models and ontologies. And as you go up that kind of line, you go from having syntactic interoperability. In other words, the field names are the same but you don't know that they mean the same thing, to structural interoperability, to semantic interoperability, where finally you know that, yep, if these two names are the same, they actually mean the same thing. And when I say mean the same thing, I'm talking now about the machine will understand the same thing from them, and it'll be congruent with what people are thinking. And that section ended up talking about, well, data these days is anything that's digital or anything that's connected to something that's digital, like a sample with its metadata. The sample won't be digital, but information about the sample will be. And we talked also about how, given that everything digital is data and everything is digital these days, how that can be dangerous because if you're not aware of what you're doing, it's very easy to basically disadvantage groups of people, perhaps with, through malice, but perhaps just through not thinking it through. And so that's the first two stories that I gave. And then, so today we're going to start with the sea ice story, which is a story I tell fairly often because it shows how data become useful and not necessarily to the same population and not necessarily all at the same time. So for about 16 years, I worked at the National Snow and Ice Data Center, and that was right before I moved to the Ronin Institute. And while I was there, the big data products that NSIDC is sort of semi-famous for are their passive microwave remote sensing data sets of sea ice in the Arctic. And those satellite-based sensors have been measuring sea ice since 1972 and started sort of doing routine data collection. So why passive microwave data is interesting and useful for people who are studying sea ice. And the answer is simply that it works in the dark and it can see through clouds. And since the poles tend to be kind of dark for 6 months of the year and very cloudy, it's really the only way you can actually study them, unless you somehow have a lot of money and can put lots of humans and instruments out on the ice. So the reason why people cared about that is that people have been studying the Arctic, since the first International Polar Year way back in the 1880s, and wanted to understand the ice and how it is changing and had changed over time. But it was really people who were interested in ice, in sea ice in particular. And so it wasn't that large an audience for these products originally. And these are the kind of products we're talking about. Is that's a daily image of ice concentration in the Arctic. So it was kind of a small community worldwide, but small because it was just the sea ice people. And for about 30 years or so, it stayed that small because it was really only people who were doing sea ice process studies and those sorts of things who were interested in that data. But that started changing at about 2002 or so, because all of a sudden the question was, are we seeing a trend? And I remember clearly going to the American Geophysical Union's fall meeting in about 2002 and listening to a talk where somebody was talking about, and when will a trend become statistically significant? And it might be another 20 years before it's statistically significant. But the minute that trend started to be visible, then a new community became interested in the data. It wasn't just the sea ice people. Now, all of a sudden, people who were studying climate became interested as well. And in the meantime, because we're talking about sea ice specialists, they developed a number of different algorithms to process the data, depending on what kind of thing they were interested in. And now they had a new audience. And so what does this new audience do? They want to know, which is the product for me. And that was hard for them because they had lots of sea ice data sets in the catalog. NSIDC has more than 100 products that are sea ice related. So it might take a while for somebody to weed through them to figure these things out. So NSIDC developed some sea ice FAQs, which tried to talk about the pros and cons of each data set. And here's just an example of that. Two of the major US algorithms are the NASA team algorithm and the Bootstrap algorithm. And they have different strengths and weaknesses and different errors and that sort of thing. And at the time when NSIDC developed this, the science community was sort of, I'm not sure that I believe that a data center ought to be doing that. Though it is true that NSIDC then and still does have actual experts in anything related to snow and ice. So I think that conundrum has been solved, and I think it's now just taken for granted that if there's information that a data center can provide that goes above and beyond what the scientists originally provided, they should go ahead and do that. But in any case, the real question became, okay, we have this new audience. Do we have the products that new audience really needs? And the answer was no. Because climatologists, people who are dealing with, trying to stick this data into climate models, et cetera, they need monthly average data. They need climatologies, in other words, averages over 30 years, for August. They need anomaly maps and trends and those sorts of things. And those are different products than the sea ice expert community needed. And so after a while of having everybody doing their own slightly differently, NSIDC decided that it made most sense to actually develop those products themselves. And so they created something called the Sea Ice Index. And NOAA, NESDIS, supported the development of that. And this is kind of what it looks like. These are obviously visualizations. The data is actually available as, spreadsheets, but they also have the images and the graphs, etc. So they're all available for download. And so you can see what they have is they have the extent and the concentration anomalies and trends on both monthly and daily basis. And they have some now tools to do comparisons and things like that online. And so that's the Sea Ice Index. And then all of a sudden that became a very popular thing for people to show in their AGU talks, etc. And also about that same time, because if you're seeing a trend and things like that, the press goes to AGU And so they might start reporting on that. And so NSIDC started doing a series of press releases related to what they were seeing with the Arctic sea ice, particularly at the end of the melt season. And it wasn't really popular in the beginning. It grew in popularity over the years. And as the journalists community also changed, the number of science reporters that existed dropped dramatically. And so the people who were ending up being assigned to cover the story ended up being all sorts of different kinds of journalists, including sports reporters, who might not know very much about the Arctic at all, like where is it? So NSIDC started fielding a lot of journalist requests that, for very basic information about the Arctic, as well as for information about, current Arctic sea ice conditions. And so it eventually became obvious that in order to minimize expense, because this wasn't actually something that people fund, they needed to create something to provide answers to these people that was easier than fielding questions all day long. And that caused the Arctic Sea Ice News and Analysis site and its related pages, which include a fair amount of information about the Arctic and those sorts of things, was born. And it started as a skunkwork project. And I mean, literally, NSIDC didn't really have funding to do it, but they had to do it because their user services staff were being overwhelmed. And they did get a little bit of funding from a NASA outreach addendum to an existing grant. But what was it is, basically this sea ice news blog. And you could look at it now if you wanted, but because the URL's at the bottom of the screen. But it's updated monthly, more or less, except for if exciting things are happening, in which case it's updated more often. It's kind of an interesting thing because it's written with sort of an 8th grade level to it, but it's the information in it comes from the science community, both NSIDC scientists and the broader cryospheric community. But the technical writers at NSIDC work with that community to make sure that it's at this consistent 8th grade sort of level, so that, the average person, and including people well outside the cryospheric field, can understand it. And it contains, imagery of current conditions, graphics, and content as conditions warrant. And it's a fair amount of information with references and links. And they're not just to NSIDC data, but also to literature and data from other places, etc. It's kind of a community effort, kind of a form of peer-reviewed science news. And this is what it looked like, I think, yesterday, maybe the day before. And yes, it refers back to the sea ice index, which is updated automatically every day. So every day you'll come in and the picture's slightly different. But then the text below is the actual blog information. So it's science information presented in a uniform, newsy kind of way. And so this is a blow up of where the data is. The blue line in the far right shows you how the ocean sea ice extent this year is performing as compared to the last 30 years. It's a little low. But life moved on. And in 2007, they had the first extreme loss of sea ice in the Arctic. And because it was extreme, media attention was extreme. And I mean really extreme. Like NSIDC made the New York Times front page top half of the fold, which is about as extreme as you can get from a news standpoint. And that pretty much made NSIDC's data, at least, pretty common public knowledge. And in fact, the factor that NSIDC had this site meant that a lot of people started looking at it sort of in a daily basis, like over coffee or something. And they're very vocal and consistent about it. I think at the peak of interest, it had about 1.2 million unique visitors per year, and it's still NSIDC's most popular page. And strangely enough, the factor that the public learned about it and a significant segment started using it also led to a request by different parts of the science community for access to NSIDC data. And the interesting thing there is NSIDC for many years maintained that, for example, the biology community probably wouldn't be interested in the products because they were so coarse resolution. It's like 25-kilometer resolution is about as good as it gets. But if that's what you can get, you might use it anyway. And I can say that, for example, the biology community uses that data all the time. I went to the final International Polar Year meeting in Canada and decided to do something totally different than my normal cryospheric stuff. And I went to a benthic organisms session, and every single talk mentioned that they were using the sea ice data from NSIDC. So I thought that was very interesting that now we have this yet again broader audience. So the number of users per year of that data set has just continually grown. And because climate change and that sort of stuff is controversial, there's quite a community that would like to, say things about that. And they can ask questions and get things wrong and that sort of thing pretty darn fast, especially now that we have Twitter and all of that. And so that meant, again, that NSIDC had to do a little bit of self-protection. And so when they saw, many hundreds of users out in the blogo internetosphere all saying something about NSIDC's data that particularly that wasn't true, they had to do something about it. And what they did about it was something called ice lights, which is a way of kind of having a communication with a two-way communication with the broader audience on the topic of ice and climate. And so basically it's a way of responding to user questions in a public forum. And for a while it was a monthly blog-like format. You could actually send your questions in, search for previous topics, and the posts, were again science community consensus results. And as well, there is a lot of information. They call it a crash course on Arctic sea ice. So if you want to learn everything there is to know about data and to go backwards, from the ice lights to the CINA to the sea ice index to the lower level microwave remote sensing products that underpin it, you can actually do that. And some people, or at least one person, has. So what was kind of the point of that story? One, it might take a long time for a data set to become truly useful and important, like decades or longer. Two, that you don't know what things in the external world are going to happen that cause you to all of a sudden have a new audience who probably doesn't have the same needs as your old audience, and for whom you're going to have to develop new data products or disappoint them, which in some cases might be a not good thing to do. So that resulted in this paper. It's out there if you want to read it. It gives a lot more background to all of this. So that's part 3, the sea ice story. And now I want to talk about fairness of data and a little bit about how that relates to audience. I don't know how many people have heard the term fair data, but I'll give you a little background to it. We'll describe what it is about 3-4 slides on. But the background is that we had talked about how data originally was something that people were even willing to die for to make sure that it survived, to the current state where a lot of data is just simply not available, but you can publish a paper even so. And so I'm claiming that data citation, the ability to find that data, which is now becoming something that all the funding agencies, et cetera, are asking for, is a re-emerging practice. That it used to be there, it disappeared due to the digital transformation, and it's slowly coming back. And, obviously the reasons for it is, you certainly can't reproduce something without it. It certainly improves transparency and ensures accountability. More importantly, in this day and age, though I'm not sure it should be more importantly, it provides credit to the people who produce the data and to the groups that publish it. And it also, on the flip side, repositories need that information because they need to be able to track usage. And if you're a repository trying to remain alive, if you can't prove that there are lots of users who want that data and who would be bad if you weren't funded, you may not be funded. And I will note that NSIDC in several periods has gone through a time where if it had not been for a very vocal user communities telling various agencies that they had to support it, it might have disappeared. It had been on the chopping block a few times. Really, if you think about it, the ethos of science requires it. I mean, how can you be a self-correcting enterprise if the stuff that people need to stand on the shoulders of giants with is not available? And when I say re-emerging practice, I want to remind everybody that, way back when, data was in the literature. It may not have been in journal articles. A lot of the time it was in books and technical reports like these two from the International Geophysical Year, but it existed. And in many cases, these books were very interesting because they'd only have like 10 pages of text up front, and then the next 300 or 500 pages would be either, well, in this case, weather charts and spreadsheets with, by the way, actual header information saying what it is in each column. In other words, metadata. But it is also true that there were places where data was in the literature as journal articles. In some fields like astronomy, that was very true. This is a paper published in '82 in the Journal of Astronomical Society of the Pacific, which at that time was the journal for publishing astronomy images. And so obviously this is at the end of the glass plate era. And so what you do is you take a print, and that would be basically the article. So why did that practice go away? And, it basically happened with digital data. And a lot of that had to do with the factor that publications were still paper and data is not. Usually it's on a computer somewhere, and computers are needed to read or do anything with it. So why would you put it in a paper? And how do you represent multi-dimensional data in a paper anyway? Because paper's two-dimensional. And also because data quickly became huge. And many journals really can't deal with lots of supplementary information. But in the meantime, there were digital data repositories spinning up in many fields, or who had been there all along, like NSIDC is the inheritor of all of that information from the International Polar Year, the first one in 1880s. But strangely enough, those were typically not associated with research libraries, or for that matter, with publishers. And more importantly, they typically had been saying, yeah, you need to cite the data for years. They might have had rules for it even, but that didn't mean that anybody did it. And so then the question is how is that being reestablished? Well, eventually it became obvious with a bunch of scandals mostly, but publishers, funders, and probably most importantly, a lot of the big scientific unions, et cetera, started realizing that basically the scientific process had been broken because the data was not available. And so a wide variety of disciplinary efforts had started happening, and in 2013, through a series of happenstances, all of those different communities came together in one place to agree to what they called a joint declaration of data citation principles, which is on the next page if you haven't seen them before. It was done under the auspices of the Force 11 organization, but this is literally a joint principles of data with many organizations having endorsed them. And clearly you can see that it's basically saying that data is a legitimate citable product, and they need the same importance as other products like journal articles, and that they should give scholarly credit and attribution. They're used as evidence. In other words, if you're saying that some piece of data is supporting some claim you're making in paper, that data needs to be cited. They need to be uniquely identified so you can actually find the stuff. You need to be able to get to it. They need to be there for a long time. Even if the data itself is too big and ends up not being available, the metadata about it has to be, and etc. You can read that. And there were a lot of organizational endorsements of that. You notice the big three are data centers and data repositories, but also publishers and, like I said, scientific unions, societies, associations, consortiums. And notice that the number of funding agencies is kind of small, but they're all the important ones. So once you have citation principles, then you need to publish it. So of course there's a paper, there it is. It's Pure J Computer Science, paper number 1. And at that point, the whole thing sort of started rolling. NISO is the National Standards Organization, and it had a standard called JATS, which needed to be updated so that journals could include data citation metadata in their documents. There is an organization that's global called the Research Data Alliance, which works to make data more interoperable, etc. And it has subgroups that are working on repository to publisher interfaces, etc. Working on metrics for citations, and even how to cite data sets that are dynamically changing. At the same time, many funders and an increasing number of funders now are requiring data management plans and data sharing. What that means is changing a bit over time as people recognize best practices. And many scientific unions and commercial publishers now require that data be deposited in repositories, be available for peer review, even if it's not publicly available, and that you better have a good excuse for why it's not publicly available, and that data is cited. For example, the American Geophysical Union has a requirement for data citation. Obviously, these kind of cultural changes take some time, so who knows how long it'll be before all papers are routinely written that cite the data, but it's becoming more prominent. And mechanisms to attach identifiers to data are becoming ubiquitous. A lot of publishers like DOIs, but some communities had other forms of identification before DOIs came on the scene, and publishers are learning to deal with that. And as a result of all of this, the FAIR data principles were developed. So on to the FAIR data principles, which are basically that if you're creating data as part of your research, that data needs to be findable, accessible, interoperable, and reusable. And when they say that, they mean that not only should humans be able to understand it, but you should be able to have all of that information in a machine understandable way. And here's the paper about those principles, which have been pretty broadly accepted by those same publishers, scientific unions, and data repositories as the data citation guidelines. And so that's sort of the next step. And so what does it mean, findable? And here's exactly what it means. This is literally the text from the FAIR data principles. So that Data and metadata are both assigned globally unique and internally persistent identifiers. People are mostly aware of DOIs, digital object identifiers, but ARCs, archival resource keys, and life science IDs are other forms of persistent identifier, and there's actually a long list. But I guess a question that you could start thinking about is, how do you make something eternally persistent? In other words, does anybody really believe a DOI is going to work in 100 years? Secondly, your data needs to be described with rich metadata using community standards, formats, and ontologies. So the problem with communities is they typically, especially scientific communities, they typically develop a discipline-specific jargon. And so if you're using a community-developed standard format or ontology, it's going to be full of discipline-specific jargon. But what if you have other communities who need to find it and who aren't in that discipline, so aren't familiar with that jargon? Okay, the metadata and data need to be registered or indexed in a searchable resource. In other words, there needs to be some way of finding it. Either it's got to be in like a Google index or the global change master directory. In other words, machines have to be able to find them. And the metadata must link to the data through the identifiers. In other words, the metadata has to include the data identifier in it. Data needs to be accessible. In other words, both the metadata and data are retrievable by their identifiers using standardized communication protocols that are open, free, and universally implementable, and if necessary, allow for authentication and authorization. The point there is not so much to put like paywalls or something in front of the data, but to recognize that there are ethical reasons why not all data can be shared. For example, it might be the location of, a protected species habitat, or a protected religious site or archaeological site, or personal information about human beings. So you need to have some way of restricting access when necessary. But again, that means that you likely have many different ways of doing that. And so again, the issue is so if I'm an investigator and I need to go get 4 different kinds of data to do my work, I might have to have go through 4 different authentication and authorization procedures to do that, which is, I think, what happens with everybody these days, where you have more passwords than you can possibly imagine. And last but not least, metadata are accessible even if the data are no longer available. That's, again, this persistence thing, meaning somewhere there has to be some long-term funding, and at least of the metadata repositories. And last but not least, the data should be interoperable. And here it's kind of interesting to me because it's all about syntax. They say that both the metadata and the data should use a formal, accessible, shared, and broadly applicable language for knowledge representation. And they talk about things like RDF, XML, JSON, and CSV. That's syntax. That's the lowest level of that ontological spectrum. You can't represent knowledge syntactically. You have to get to it semantically. What does the word bear mean? Is it a bear in the woods, or, is somebody bearing a child? What's going on here? You have to understand the context and the meaning, the semantics. And then you're supposed to use vocabularies that also follow the FAIR principles. And the question is, so if I've got 2 data sets, they use different representations and vocabularies, how do I make them interoperable? What is required to do that? And then last but not least, that everything has to have qualified references to everything else that it's related to. And I wanted to just bring up, this is their definition of interoperability: the ability of data or tools from non-cooperating resources to integrate or work together with minimal effort. I would claim that if you have 2 data sets that use different representations and vocabularies to make them interoperable, probably is not going to have minimal effort involved. And then last but not least, reusable. That Your data and metadata are richly described with a plurality of accurate and relevant attributes. I guess you have to ask relevant to whom and what do you do when there are new audiences? I have an example. Geologist took a lot of images of rocks in the dry valleys of Antarctica because he was studying the volcanic plumbing there. But incidentally, all of those photographs included glaciers that were in the area and basically how those glaciers changed over the period of his career of 40 years. But to know, what glacier it was and how it was changing required that you knew what direction the guy was standing when he took the photographs. So just knowing that he was, at a particular lat and long was not good enough. You needed to know the direction he was pointing, which is not something the geologist actually had because he was only taking it for different reasons. And that data be released with clearly understandable licenses, that there be detailed provenance. I'm not sure what that means, and I'm not sure who it often serves, and that it means domain relevant community standards again, which again has the semantics problem of jargon. So with all of that, here's just some big picture questions that you might want to think about or maybe have a conversation about, like who's responsible for the work needed to make that well-described data? It's obvious who's responsible for the work to create a journal article. And I suspect that everybody's thinking that the same should be true with data. But that would, require a fairly large cultural change and literally to make data publication as important to one's career as journal articles are. It totally leaves blank the question of who's responsible for dealing with the question of new audiences. I mean, people often think, oh, I'm going to publish my data, that'll make it, available to decision makers. Well, that's not true either. NCAR recently did a workshop with a bunch of people who were citizens in an area that had hurricanes, because NCAR does a lot of atmospheric work with hurricanes, and discovered that just simply telling somebody that, there's going to be a 16-foot flood tide is not helpful for them to make decisions as to whether to abandon their house or not. But if you actually showed them a picture of their house with a water line at the second story window, that was helpful. Who's responsible for basically getting from the science data to it can help a public make a decision or a decision maker make a decision? And then how can data using different representations of vocabularies become interoperable? And last but not least, this FAIR thing is being pushed very strongly by unions, scientific unions, ICSU, for example, publishers, and data repositories. But given that a lot of the problems that science needs to help with solutions are transdisciplinary or at least interdisciplinary, is FAIR going to be good enough? And last but not least, just because I've been on the inside of data repositories for a long time and they are not a comfortable place to live if you like stability of financing, is anybody ever going to step up to fund repositories for the long term? I mean, where is the equivalent of the library for data? And that's it.
Excellent. Thank you.